Welcome, everyone. My name is Tomasz Pęczek. I'm here today to guide you through Azure Functions extensibility. I will assume that because you are here, you know what Azure Functions are. You know that they are the key part of Microsoft's serverless offering. You know that they are the compute power behind the Azure serverless stack. But that's a sales talk, right? What does it truly mean? It means that the sole purpose of Azure Functions existence is to give you resources to run your business code. Is to give you abstractions so you can forget about the infrastructure, focus on your business code. This is directly reflected in Azure Functions logo. Those angle brackets, they are supposed to signify the focus on the business code. And this is not an easy task. Business code doesn't run in vacuum. It requires context, some data to process. It may need to produce some data. It needs to react to external events. And Microsoft does provide, out of the box, a number of integrations, ways to communicate with Cosmos DB, react to HTTP requests, work with queues. The list is pretty long. Obviously, it's not exhaustive. It cannot be. Microsoft cannot provide integration for every possible technology out there. They do that for the most popular ones. They do that for the other parts of Azure. That's their business, right? But at the same time, their business is to make as many of us as possible use Azure Functions. So in addition to that out-of-the-box list, Azure Functions also contains an extensibility framework. And this framework allows you to create three main types of extensions that directly map to those area of the context for your business code. Inputs, so you can get any data you need into your function. Output, so you can produce some data. And that integral part of Azure Functions, triggers. So a way for your functions to run in the result of an external event. So whenever you see an infrastructure code, some of these responsibilities sneaking into your function, your mind should go toward the extensions to extract that code. And when you get there, you may end up, as I did, looking into docs.microsoft.com. Microsoft documentation has made a tremendous progress through the last couple of years. It's no longer an anemic API description. It contains walkthroughs, guidelines, best practices, articles. I haven't found anything about Azure Functions extensibility. The knowledge is out there. If you look hard enough, you will find GitHub wikis, Twitter discussions, even source code. A number of integrations provided by Microsoft is built on top of that extensibility framework. So if you are persistent enough, you will gather the knowledge needed to create Azure Functions extensions. And when I went through that exercise for the first time, I've decided I want to help. I want to give something to the community. I have created a couple of articles, some demos, and my initial idea for starting point to all of this was this diagram. Nice, colorful, completely useless when it comes to learning itself. Well, diagrams tend to be like that, right? Especially if they are nice. If they are nice, they are missing context, there are not enough information. So this diagram actually ended up being a nice quick reference. If you are already familiar with Azure Functions extensibility, you can quickly find things here. Completely doesn't check when you want to learn yourself. Today, I want to use this diagram in a little bit different context. I want to use it to teach you. It will be my map. I'm taking you on a tour. We will visit different parts of Azure Functions extensibility. This will be our map. And every decent tour starts with the orientation. That's the part when the guide comes in, gives you the earpiece, gives you the sound device, and shares with you some background, historical context, some important information. In context of Azure Functions, this will be about the boilerplate code. So all the code that every Azure Functions extension needs, and some components that every Azure Functions extension can use. This is when I'm actually going to answer the question, how do you start writing an Azure Function extension? And I guess none of you will be surprised that I tell you, with a class. Of course, not any class. It has some special requirements, starting with Interphase. And something interesting is already happening in that first very moment. You can immediately see that you are inside the Azure Functions hosting layer. Of course, the fact that Azure Functions is running on top of web jobs, that's not a secret. It's right there in the documentation. But when you are working with Azure Functions through the code, you don't see that. The abstractions are high enough to hide all the implementation details. When you are writing extensions, you are below all those abstractions. You are directly cooperating with the hosting layer. This class needs to be used by the hosting layer. How does that happen? Who of you is familiar with ASP.NET Core? Okay, me too, a little bit. So for people like us, the instinct is, this will somehow work, right? This is what ASP.NET Core does to you. It's strongly based on conventions. If things are named properly, have proper interfaces, most of the time they will work. Not here. Here you need to be explicit. So if you want your startup class to be used by Azure Functions Hosting, you need to tell it how to do it. And you do it with an assembly level attribute. This immediately tells you something about how to package your extensions. They are meant to be assemblies delivered via NuGet. There should be only one attribute per assembly, only one startup class. That also suggests that in order to achieve a certain cohesion, your assembly should be about either a single technology or a single concept. Well, of course, nothing prevents you from mixing like completely unrelated extensions together. It will simply be a mess. Hard to use, hard to understand, hard to maintain. So try not to do that. So once you point the Azure Functions Hosting to your class, it will instantiate it, it will call the configure method, and it will pass in the builder. And with that builder, we can finally start building our extension. We can register something which is called extension configuration provider, right? It wouldn't be .NET if there would be like at least one class with some enterprise class level naming. So this is it. Extension configuration provider. A question may arise here. Why don't we start with extension configuration provider? Why there is no assembly level attribute pointing to it? Well, we can guess that this builder gives us additional capabilities. First of all, configuration. So you can configure our extension through external sources, other files, etc. But more important, we are being given access to dependency injection. You can register your services here, and any class which is instantiated by Azure Functions Hosting can get those services injected through the constructor. Extension configuration provider is one of those classes. This is just a class, yes, it has a special interface. It has some kind of attribute. Those descriptive attributes, there is a couple of them when it comes to Azure Functions extensibility. They are mostly used by either logging or the portal, or when you are working with not managed functions, so with functions.json. Then those values, they are important, so it's better to put something reasonable in there, something that points to your extension. But at the end, this is just a class. It will be instantiated by Azure Functions Hosting. It can leverage dependency injection, and Azure Functions Hosting will call the initialize method. And in that method, we can finally start defining our extension. We do it with a binding rule. Binding rule is an abstraction. It's a container. It contains relations. Relations between the attribute, that's the marker. That's what we put on our functions, parameters to tell Azure Functions Hosting which extension it is supposed to use in given context. And on other part of these relations are different components that represent different type of extensions. The other thing you can do in that initialize method is register converters. And those are standard .NET converters based on iConverter interface, and they opened additional extensibility techniques. I will get back to this at the end. So this is the boilerplate part. This is what you need to have for every extension. When you know this part, you can actually start writing something. And I'm going to start with inputs, because from technical perspective, inputs are the simplest one. They are easiest to implement. They are built around a single concept, the concept of value binder. So whenever you want to create an input extension, you need to create a relation in your binding rule between your attribute and some representation of value binder. There are a couple representations of value binder and even more ways to define those relations. I would like to show you two of them which, in my opinion, are the most useful one. Let's start with an example. This is a very simple function, right? Whenever timer elapses, it makes an HTTP request. That's a health check, essentially. That's what it does. A simplified one, of course, like logging from health check makes no sense. But this is enough to show a problem we might want to tackle. The problem is HTTP client. HTTP client is very commonly used class in .NET in general. At the same time, it's very hard to use properly. The infamous improper instantiation pattern. Long story short, if you have too many instances of HTTP client, you can end up in socket exhaustion scenario that will crash your software. For Azure Functions hosting, that's deadly. So the simple guideline is reuse your instances. In case of Azure Functions, that means a single static instance. This is coming directly for best practices for Azure Functions from Microsoft documentation. At least it was there a couple of weeks ago. I haven't checked yesterday. But it's probably still there. And this solves the problem of socket exhaustion scenario. But it brings new problems. Having a single static HTTP client instance doesn't play well with DNS changes. It can also cause high CPU usage in certain scenarios. So, the current general best practice for HTTP client is have a certain amount, a pool of instances, and recycle them from time to time. And this is as terrible guideline as it sounds. We developers, we hate guidelines like this because they are no strict. Certain amount, from time to time. How the hell do I implement that? So the ASP.NET Core team decided they will help us. They will try to. They have created a strongly opinionated, obviously, HTTP client factory, and then didn't couple it with ASP.NET Core. It only requires Microsoft.extensions, dependency injection to work. And it so happens that internal dependency injection, available when you are creating extensions for Azure Functions, is also based on Microsoft.extensions, dependency injection. So we can try to use HTTP client factory in context of Azure Functions, maybe with extensions. What we need is an attribute. That's the starting point. And those attributes, depending on the extensions you are trying to implement, tend to be very different. They can be very simple, like this one. But more often, they have a number of properties, because those properties are the only way to configure an extension at function level. And Azure Functions gives you a number of attributes you can apply to those properties, so you can bind them to either configuration files or different parts of the current context of Azure Functions. Here we are going simple, like grabbing HTTP client instance doesn't require any configuration. So we can create our binding rule and define relation with some representation of value binder. In this case, we can go with the simplest way, calling bind to input. And that's a generic call. Most of the calls we are creating those relations that represent extensions are generic. And the type of generic parameters defines what is the supported type of the function. So in this case, we are simply telling the parameter on the function must be HTTP client. Otherwise, it won't work. And the representation of that value binder is a simple function. It's a function that takes an instance of our attribute, if you need any kind of configuration, and it's supposed to return a value for your parameter. In this case, HTTP client from HTTP client factory. We have our HTTP client factory from the constructor, from dependency injection. That means that when we are registering our extension, we are also registering HTTP client factory. Simple. It works. This makes this function possible. For every call, an HTTP client instance will be injected, and it will be managed by HTTP client factory. This is actually one of the reasons why I have chosen this example, because it's simple. There is very little noise coming from HTTP client factory as a technology. Almost all the calls are about the Azure Functions extensibility. But there's a second reason. This example allows me to pull the oldest teaching trick on you, show you how to do something, and then go like, nah, we no longer do it like that. We are smarter now. We know better. This kind of extension solves a certain generic problem, injecting dependencies into your functions. And that truly was a problem for a very, very long time. It deserves its own story. Who of you has been working with Azure Functions version 1? Okay. So those of you truly know how shamefully long the road toward dependency injection was for Azure Functions. For the rest of you, the lucky ones, I'm going to spare you that part, that dark ages, and I'm going to start this story at Azure Functions version 2 GA, September 2018, year ago. We are being given the current version of runtime for Azure Functions, like in general, it had changes, and the current version of extensibility framework. With that dependency injection available when you are creating extensions, with no dependency injection available when you are creating functions. This is why extensions like the one I have just shown you has been created, to leverage, to surface that dependency injection capability to those who are implementing functions. There were even more generic attempts to do it. They had their problems, mostly because how Azure Functions discovers extensions, so there were problems with proper registrations of your dependencies. But people were trying because they had no other choice. But this was like a year ago, right? We should expect things to change. So fast forward like 4 months, January 2019. Azure Functions are being given support for instance methods. What does it mean? It means that our sample function can now look like this. Okay, another big change, right? Like 1 keyword missing. But this was actually important. Thanks to this change, first of all, Azure Functions could not be properly tested. We can use normal testing scenarios with static methods testing is not that good, so that was very important. The other thing that it enabled was inheritance. And I'm not sure if that's a good thing. Generally, inheritance is a good thing, but for Azure Functions, that's usually a smell. If you come to the point when you think you need inheritance in your Azure Functions, something might be going wrong. You should think really hard about it. Of course, they are special cases, right? It's not always a bad thing, but most of the time, something bad is happening. But this was also a very important milestone from the perspective of dependency injection. Doing dependency injection with static methods is awkward. You either have to have like parameters with attributes, so what I did in that extension, or even some more crazy API. Generally, that's now how we are used to do dependency injection. So the Azure Functions team wanted to give something standard, typical. So when new people are coming to Azure Functions with their normal .NET background, they know what to do. So they used this milestone, and on top of it, another 4 months, so May 2019, not that long ago, right? They have finally delivered dependency injection available when you are creating functions. This is now possible. This is what you are expecting, right? Your dependency is being injected through the constructor. You can use it in your method. It's getting created for every call of your function. It's getting managed by HTTP Client Factory if you register it properly. How does registration look for Azure Functions? Well, it's surprisingly similar to creating extensions. Once again, you need a class, a special class. You need an assembly-level attribute pointing to it. This time, this whole thing goes into your Azure Functions project. So you keep your registrations with your functions. And once Azure Functions finds that class through your attribute, it will call the configure method, it will pass the builder, you will have that Microsoft, that extensions, that dependency injection API. You can register whatever you want. It works exactly the same as in ASP.NET Core. Well, you might feel it works differently. That's because how triggers are behaving. Simply the scopes mean something different. But in general, that's the same thing. So dependency injection is a solved problem when it comes to Azure Functions. If you encounter extensions like the one I have just shown you, don't use them. Rethink them. Re-implement them on top of that dependency injection. You will have less code to maintain. You will be happier. What you should use input extensions right now is what they were truly meant for, getting data into your functions. So my next example will be based on RethinkDB. Okay, yeah, I know. Not that popular database those days. But it was popular some time ago. And in software development, if something has been popular some time ago, there is most likely some production software still running on top of it. That's how the industry ran. And I was lucky. Let's go with that. I was lucky enough to help in a project which was moving to the cloud, and they had RefingDB as part of their core infrastructure. Now, moving database into the cloud, that's not a challenge, right? You can grab a VM, you can put it into container. That's not a problem. But for new functionalities, they wanted to use Azure Functions. No surprise there. They have a cloud now. They want to harness its power. That created a challenge of communicating between RefingDB and Azure Functions. In the result, a number of extensions has been created, and they were kind enough to allow me to open source them, put them on GitHub. Somebody downloaded them. But it gives me also an example to show you how this is done in more complicated, more sophisticated scenarios. So how an extension for grabbing data from database or something more real looks like. First of all, that attribute, it's a lot more complicated, right? Every configuration you need to have, that needs to go here. So your table name, connection string, any other stuff, it has to go there. You either provide values directly when you are putting attribute onto your function, or you can bind them to like a configuration file or something else. And if there is a configuration, that means that your binding rule will also be more complicated because you probably want some validation. And Azure Functions allows you to do it. You can register validators with your binding rule. They will validate your attribute, the current instance of this attribute. They will also be given the type of the parameter that it is attached to, so you can use that. And based on those two information, you can validate. If something doesn't end up, you are missing something crucial like connection string, you can terminate the flow, errors will be logged, function will not be executed. If everything is fine, only then those relations will be evaluated. And here, that simple relation from previous example is no longer good. We are dealing with database, right? We have multiple tables in database. We want to deserialize them differently based on what's the format of the data. So having a generic call that works with a single type, that's not going to cut it, right? That's a problem we need to solve. So here we are taking a different approach, but before I go there, I want to bring your attention to the call which is just before that bind to value provider. When is not null, name of ID property on the attribute? What is that? Okay, that's a condition, okay? That's visible. But why it is there? To distinguish. That comes from the common practice of how many attributes you have if you have a full set of extensions for certain technology. The common practice is two. One is for bindings, so inputs and outputs, and the other is for triggers. That means you have to somehow distinguish input from output. And this is usually quite easy to achieve. They either work with completely different types, or there are some logical conditions that can tell you when this is an input or what is an output. In this case, if there is ID on our attribute, that's an input. We want to grab data from database. If there is no ID, it's an output. Triggers have separate attribute for like two main reasons. One is triggers are conceptually very different than bindings. So it makes sense to separate them. The other thing is, when used, triggers look exactly the same as inputs. It would be really hard to distinguish one from another. There's like no simple rules what you actually want. So once you have your condition in place, you can define your relation. And here, we are using the second most popular way for creating input extensions, bind to value provider. This again requires a function, but this time this function is a factory. It will be given an instance of your attribute for current call, the type of the parameter, and it is supposed to produce a proper instance of value binder. How? With reflection. If you have a generic implementation of value binder, you can easily use reflection to create an instance specific for the current type of the parameter. The value binder itself, it has a very simple API. It's generally technology specific. If you are interested in that version for RefingDB, it's right there on the GitHub. It just opens a connection, grabs data, deserializes them, nothing particularly interesting. But if you go this path, you will have this. A standard extension, which was exactly like anybody who is familiar with Azure Functions, has been working with Cosmos DB or anything else, is expecting to behave. Parameter, attribute, configuration, it works. Now you have data for your business process. How to produce data out of your functions? Well, outputs are logically very similar to inputs. They have the same concepts inside. The implementation is a little bit different. The key concept here is a collector. So whenever you are creating an output, you need to create a relation between your attribute and the collector. And to do that, the best call available is bind to collector. And this is a generic call, again. And I just said that generic calls are not good in case of Azure Functions if we are dealing with databases, right? Because they limit us. We want to support multiple types. But here, Azure Functions gives us a hand. The parameter for this call is a converter. And it can be a generic converter if we use a special type delivered by Azure Functions, which is called OpenType. And OpenType basically means everything. I mean, you can inherit from OpenType. If you do that, you will be given a method that you can override. And in those methods, you can limit what you actually support. But just using OpenType means everything. And that converter that you pass to that call is nothing else than a factory. It has the same task as that function has in the previous example. It needs to create an instance of value binder based on an instance of the attribute and the type of the parameter. So that collector which you return, that actually does the work with the database. And it's actually quite interesting. It is worth to take a look at it because it has a simple API, right? 2 methods. And it would be extremely easy to implement it if the methods were doing what they are actually named. In most extensions, the add doesn't do the add. And there is a reason for that. If you look at this interface, something is missing. There's like no way to update. If you are dealing with many data sources, databases especially, you probably not only want to create new data, you want to update existing ones in certain scenarios. So for most extensions, starting with the ones from Microsoft, add is actually an upsert. Depending on some logical condition inside, it either performs an add or on an update. Also, that add call is the only place you can put any logic in your collector. So if there's anything else you need to do, for example, I don't know, create a table. If there isn't one, you have to do it here. What's more, many extension authors, they put the actual persistence code also here. There are 2 reasons. First of all, Microsoft has started doing it like that, so people are adjusted to it. And there is like nothing that enforces a contract between the function and the collector. So in the result, for most extensions, flush is just a no operation. You don't do anything there. You do anything you need to do in add method. Then it works exactly as everybody are expecting. You have your collector as a parameter, you have your attribute, you can call add on the collector, you can await it, it will work. What else will work is this. Azure Functions, when it comes to collector, is capable of doing some magic for you. If it observes return values or output parameters like this, it will wait for function to run, it will go to your extension, it will grab an instance of collector, and it will call the add for you. This all works out of the box. So you only implement that most complicated way of producing data. Azure Functions gives you the simple ways, so you don't have to worry about that. And that's it if you want to producing data. So inputs and outputs are quite simple, similar to each other. Triggers are not. Triggers are a completely different beast. And there is a good reason for that. If you really want to, you can do what inputs and outputs are doing inside your function. From technical perspective, that's possible. You can open a connection to a database, grab some data, create some data. It will work. It's ugly. It's probably the worst thing you can do with your Azure function. Well, there are worse things, but it's very bad. It should be about your business code. Triggers with triggers, that's impossible. Triggers have to be outside of your function because they are the reason for your function to run. So triggers have to be tightly coupled with the hosting layer. They need tools to trigger functions. So triggers have their own hierarchy of classes with multiple responsibilities. You still start with that binding rule. That part haven't changed, and you still call like bind to trigger to create the relation. You can probably guess that. And this is still a generic call, as most of those calls are. And here, I would strongly advise you not try to use OpenType. It's possible, but that's not the best way to go forward. You should choose a type that provides the most information about the event which has just occurred. Yes, this is still a database scenario. You want to support as many types as possible, and there are other techniques to do it. I will show you. But here, you should focus on that single type which gives you the most information about your event. Once you have that single type, then you can start building your trigger. And you started by providing, again, a nicely named enterprise class level naming class, trigger binding provider. And it has a single purpose. Try to create a trigger binding. Why try to create? This comes for the fact that Azure Functions calls this method in an unusual way. It will call it for every parameter on the function. Why? Well, I don't know why. And simply does it like that. It certainly enables some crazy scenarios if you want to be like extremely unusual and do something weird, but most of the time you won't. That's not what you want to do. So what you have to do here is check your parameter, check if that's the parameter which has the attribute attached, because probably that's the one you care about. If that's not this parameter, then you need to return null, of course, wrapped in task. That method has an asynchronous signature. If it is the parameter you care about, then you are returning a trigger binding. A trigger binding has several responsibilities. First of all, it needs to confirm that type you are supporting, that most descriptive type about your event. The second thing is, it needs to provide some descriptive informations. This is mostly used for logging. If you have ever been looking into a console while your Azure Functions are running, you have probably seen those entries, functions, something, something has been triggered by something, something. So this is coming from here. So how well you will structure this information, that well it will appear in your logs, in your console. It also has a method and property that you shouldn't care about. Like, it's right there, it has default values, forget about it. It's for like very unusual scenarios, and you almost certainly won't end up in them. So just know what to put there, forget about it. Focus on more important things, like creating the listener. Listener is the part of the trigger which actually does the job. It hangs in there in the background. It's listening for your external events, and it's triggering the function. So it needs a tools to do it. First of all, it needs some kind of an API to trigger functions. And Azure Functions Hosting will give you this API when it calls that method. Inside that context, there's a property, executor. It contains the API for triggering functions. So you need to pass that to your listener. You also need to pass anything else that your listener needs to do its job. So anything you have grabbed from dependency injection earlier, and you can pass down any configuration, that's your job. When listener has everything it needs, it can start working, and it has an API that will be familiar to any of you who is working with ASP.NET Core. Hosted services in ASP.NET Core, they have a very similar API, because that's the simplest API you can have for a service which is running in background and needs to be in line with its host lifecycle. So the same patterns that are good in ASP.NET Core for hosted services are also good here. This boilerplate code is quite good as long as you implement the listen async correctly. So let's focus on it. Here I will dump some RefingDB code on you to give you like full context. So the important part is to keep an eye on that stopping token. So whenever you can, for example, in RefingDB, you cannot cancel opening a connection. So that has to go through. But creating a change feed in RefingDB, yes, RefingDB has change feeds. It was actually a first database ever to have change feeds. Simply there was like no serverless back then. And there were like no good usages for change feeds in those times. So RefingDB was simply too early. Now Cosmos DB, MongoDB, they have change feeds. More databases will have change feeds. That's the glue between databases and serverless. It also has other usages like outbox patterns and etc., but that's crucial for serverless. So RefingDB has change feeds, and when you are creating that change feed, you can pass that stopping token. So this will be canceled. You need to remember about that. And when you have that change feed or whatever else stream of event that is important for you, you can actually start listening. And you should be listening for two things. Either that stopping token gets triggered. That means you need to shut down, clean up, because the host itself is getting shut down. Or an event arises from your stream. Then you want to execute a function. Then you need to use that executor API you have been given, you have yourself passed to your listener, and you need to try to execute a function. And you need to pass an instance of triggered function data and set the trigger value property. This is what will be passed into your function. And this is a fully functional trigger that will react to new data appearing in your stream, that will trigger functions. Yes, it still has that limitation of supporting only that certain type you have chosen. This brings me to that additional extensibility technique or trick, extending extensions. It's based on converters, as I mentioned in the beginning. And okay, let's look at an example. This is a simple function that is using Cosmos DB trigger, right? And Cosmos DB trigger has a certain inconvenience when you are using it. It only works with read-only list of documents. And that's in line with the guideline I have just given you for creating triggers. Use the most descriptive type for the event which has just happened. So this is the best thing that there is for Cosmos DB in this context. At the same time, it's not what we usually want. Usually in functions like this, you want the data. So the first couple lines of most functions which are using Cosmos DB trigger is about either converting that document or extracting some data. This is infrastructure code. This is not a code you want into your function because it should be about the business code. And there is a way to deal with that. If you create an extension that registers a converter, then that converter automatically applies to all the currently registered extensions, because the converter manager is shared between all the extensions in the Azure Functions hosting. In general, Azure Functions works like this. If they see a parameter on a function, which is either a trigger or an input, or even an output, and it sees a certain extension attached to it, then it will go to that extension and it will check. This is the parameter from the function. This is the parameter that the extension has declared. If they are matched, perfect, we are good to go. If this area is open type on this side, that's good as well. If this doesn't match, then Azure Functions will make one more attempt. It will go to the converters manager, and it will ask, is there a converter between this type and this type? Or maybe something with open type in between? If the answer is yes, and if we create an extension that registers a converter, so in this case, a generic converter, which is actually defining a conversion between a read-only list of document and read-only list of open type, the converters manager will return that converter. That converter obviously needs to be able to do its work to actually convert, but it will make this possible. You will be able to put something else that the original extension author didn't plan for. You are responsible for conversion, but you have just removed the infrastructure code from your function. And this is a very neat technique. It allows you to keep that best practice for your triggers of having the most descriptive type, while still supporting any other types you want. It allows you to extract any common translation, conversion code you may have in your Azure Functions. Because that's the main thought behind this talk. If you are supposed to bring like one thing out of this room, that's it. Infrastructure code doesn't belong into your function. Your function should be about business code, and extensions are the way to do it. Thank you. If you have any questions, feel free to ask. If you prefer to ask them like more privately when everybody will be leaving, feel free to. If you want to grab me as part of the hallway track, I'm out there. If you will have questions when you will be actually implementing some of this stuff, reach me on Twitter. My DMs are open. I'll try to help you. Thank you.